Today we're going to speak regarding chapter 5 about sequential circuits, and also um, we will analyze the 7 segment assignment which you had. And now we will start to have some review question. Some of them are with answer, some of them without answer that we are going to share today. And you can have it on the mock system. As I tell you, try to solve as much as you can the question. And if you have problem, please ask me. Also, what I have done about some question regarding the multiplexer, that we have the video for that. I'm going to share that with the answer on the mock system. Also, you can have the answer question all, and also some video regarding that soon. Some more video I will add to the mock system, that I will solve it on the board and take the video with my mobile phone. I think maybe it should be the better way and effective way for this subject, that if we can have more number of assignment and task. And then chapter 4 was very important. Chapter 5 is also, it's one of the most important part. Mainly in the previous semester, the question is from chapter 4, 5, 6 directly, and you should know the previous one, because we have some midterm for the previous chapter. But now I think we have more number of questions if we cannot have the midterm exam. Today I will confirm with the school what should we do for the midterm exam, and how we should conduct and solve that also. And we'll inform you soon. Just please follow the uh, statement that I will put soon on the group. Okay, let us start and then don't waste time. Um, Today we are going to speak regarding the sequential circuits. What we discussed till now, that was about combinational circuits. And in the new circuits that we want to speak, it has some more part which depends only on combinational present inputs. And also we have some more part, as you will see, that we have some memory elements, which it will make more ability to our circuits, which can remember some output, exactly the last output or last status that we have. Now we can remember in this sequential circuits that we say. Let us compare these combinational logics and sequential logic. Combinational logic is previous design that you have done till now, and in them current output depends on the current inputs only. Where we can use them as arithmetic logic unit or ALUs. We can use them in multiplexer, or we can use them in decoders and any gate design. But the new concepts that now we are searching for, that is sequential logic, which is current output depends on the past input, as well as again current input. And then we have some terms like memory, which generally it will named as state. Then which elements we have here? We have some elements that we can call them latch, flip-flops, state machine, counters, and shift register. It means that the next two lecture chapter 5 and chapter 6, we are just talking regarding the latch, flip-flop, state machine, contours, and shift register. Please be aware that we are going to introduce some new terms, some new tools, which now they have the memory. One thing that I want you to know that this memory is the basic form of the memory or elementary form of memory that it can extend and become the real concept of memory. Because if we talk regarding the memory, generally we are thinking for something like USB flash drive that we have. But something that just now we have some state memory, one and two. Means that in this memory, maybe you cannot store the character, okay? But you can store just the one or zero, previous state. Then please be clear for this term of memory if we say memory. If I want to introduce the sequential circuit, I can say that their contains a set of inputs and output. And the output of sequential circuits depends not only the combination of present input, but it's also uh, it's also depends on the previous output, which previous output is nothing but the present state. Therefore, for the sequential circuits, it's contain again some combinational circuits along with the memory of a storage element. Some sequential circuits may not contain the combinational circuits, but only they can have the memory also elements. Again, these circuits, I want you to know that we have input, we have combinational circuits, and output, but we have some loop or some feedback here, or as they say, some hmm, memory remember part, which in that there is some clock pulse, okay, which will give the command to this part, which we call it flip-flops. And based on that, because now we are thinking for last state. Last state means last time output. It means that you should have some clock, you should have some reference time for that, which generally it's in the form of some pulse, as we can see here. Then this clock will show us the previous pulse or pulse number 1 or pulse number 2 or pulse number 8. What was the real status of our circuits? Let us compare again the combinational circuits and sequential circuits, which I show them in this table. As I show in combinational circuits, the output depends only the present, but in sequential one, output depends on both present and present input and present state. In combinational circuits, feedback path is not present, but in sequential we have the feedback path, and memory elements are not required for the combinational circuits, but for sequential we have the memory elements. Clock circuit is not required, but we have the clock in sequential one. In combinational circuits, it's very easy to design, as you saw with the help of K-map and Boolean algebra. You can design your circuits, but somehow in sequential circuits, it's difficult to design. Um, that was the comparison between these two terms. But let us see which type of sequential circuits we have. We have two type of sequential circuits: asynchronous ones and synchronous ones, which it shows the dependency of the time and the dependency of your output based on the pulse or clock pulse that you saw in the previous circuit. Uh, I mean that in the asynchronous ones, if some or all output of your sequential circuits do not change with respect to the active transition of clock signal, then that sequential circuits, we can call them asynchronous circuits. That means that all the output of these type of sequential circuits do not change at the same time. They can change in various time reference. Therefore, most of the output of this type of circuits are not in synchron with the either only positive edge or only negative edge that we will talk these two positive and negative edge part. Um, with respect to this time, again we have one more term that we call it synchronous. And in the term of synchron, we can say synchronous. In terms of asynchron, we have another terms that we call it synchronous. And in synchronous, all the output of them affect with respect to the active transition of clock signal. Then the sequential circuits, it's called synchronous sequential circuit. It means that all output of synchronous sequential circuits can change or affect at the same time. Therefore, the output of these type of sequential circuits are in synchronous with either only positive edge or only negative edge of clock signal. But let us see what is clock signal and how it can manage our circuits. What this is the main part that today especially we are going to talk regarding that. Uh, as you will see, this clock signal is in the form of pulse. This form that I shows here, we call it pulse. Pulse means 0 and 1. Okay. And somehow they call it train of pulse, as you will see here. It's something like train that it has 0 1 0 1 0 1. It can have these values sequentially. This clock signal is periodic signal, and it's on time and off time. On time in the sense that the value is 1 or 5 volt, and off time, which means that the value is 0 or the pulse is 0 here. We can represent the clock signal as a square wave when both is on and off time are same. And this clock signal will show here means that the period that we have on and period that we have off is little bit they are same. Um, you will learn later regarding this pulse. I don't think in this subject, but maybe you have some example that I will solve even by hand. You will see that Sometimes we can have more on time and less off time, something like that. That is also a form of the pulse that we can have. Don't forget that there is some terms that they call it PWM or pulse width modulation, which is not mainly related to our topic, but um, how we can have suppose more on time and less on time, it's depend on this concept of PWM, which we will talk later. As you will see in this figure, the square wave is considered as clock signal, and this signal stays at the logic of high or 5 volts for some times and stay at logic 0 or 0 voltage for the equal amount of time. Equal amount of time means that on and off time are same or time period is same. Or if I want to tell you in the terms of PWM, it's 50%. 50% on, 50% is off. Let us talk more about this time period that this pattern repeat with some times period. In this case, the time periods will equal to on and off, and we can represent the clock signal as the train of pulse, as I tell you already. When on and off time are not same, this clock signal is shown is in the figure, and train of pulse, we call it as clock signal, and the signal stays at logic high or 5 volts for sometimes and stay at logic 0 or low for some other times, which this pattern repeats with some time period. In this case, the time periods will be equal to turn off on time and off time as shown in the figure. But there is some relation between time and frequency. Maybe you saw it in your physics subject before. That you should know that there is the relation between time and uh, frequency, which is one on frequency is equal to time. Or we can say that the reciprocal of the time period of clock signal is known as frequency of all the clock, and all sequential circuits are operated with clock signal. So the frequency at which the sequential circuits can be operated accordingly, the clock signal frequency has to be chosen. And now we can maybe have some idea that why we talk regarding the time and frequency like that. There is some terms that we call it triggering. Triggering is something like sensitivity, not exactly sensitivity, but anyway, we can say sensitivity. Or we can say what should be the um, reference of looking to the circuits. We can call it triggering. We have two possible types of triggering that we are using in sequential circuit. One is that with changing the level, as you will see here in the first one, level is changed. Level was 0, now it's become 1. Means that the level is changed. Again, level was 0, is changed to 1. Level was 0, changed to 1, and so on. But for the previous one, we can say the edge triggering, means that it's going high or it's going down. Okay, we can see them even better. For the edge one, we have some positive level edge, means that if the sequential circuits it's operated with the clock signal when it's when the clock signal, when it's in a logic high, then that type of triggering, we can call it positive level triggering, as it highlighted in this figure. Or if the sequential circuits is operated with the clock signal when it is in a logic low, then that type of triggering is known as negative level triggering, as I show it here, that we have the uh, negative level of triggering. Uh, that was for negative level or high level of triggering. But edge triggering, these are two type of transition that can occur in our clock signal, and that means the clock signal transition either from logic low to logic high or logic high to logic low will happen. Following our two type that we talk, positive or negative one, and if the sequential circuits is operated with the clock signal that it transition from logic low to logic high, then that type of triggering we can call it positive edge triggering. It's also called as rising edge triggering that we can see in this figure. See, please see the uh, arrows that I shows here. If you see the for the yellow one, let me show you better with the pointer here. Please see the arrows. We are going from logic low to logic high. Then this type of triggering, we will call it positive edge. It's also can call rising. It's something like that. You are going to rise the flag, okay, of edge triggering. But on the other side, for the green one, if you see the arrow, please, place of arrow. It's going from high level to low level, okay, which we call it negative edge. It's also can called as falling edge triggering, and it shows here. The classification of sequential logics show us as standard logic gates are the building of blocks of combinational circuits, pistol latches, and flip-flops are the basic building blocks of these sequential logic circuits. And sequential logic circuits can be constructed to produce either simple edge trigger flip-flops or more complex sequential circuits such as storage register, shift register, memory device, or any other counter. Uh, if we want to see the classification of these type of circuits, we can see this graph that I bring for you here. Please have a look. We have sequential logic circuits, which they are event driven or asynchronous. They are click driven based on clock. We call it synchronous or pulse driven. Okay, they can be cyclic or non-cyclic. Event driven means that the asynchronous circuits that change the state immediately when enabled, and clock driven are type of the logic circuits which synchronous circuits that are synchronized to the specific clock signal, and pulse driven, which is combination of two that responds to triggering pulse. Um, we can say the sequential logics, we have some important terms in that. One is that clock, which is the master or reference for timing elements behind the state of change of most sequential circuit, it can be the clock signal, which can be active high if the state change occurs at the rising edge, and active low if the state change occurs at the falling edge. We have another term that we call it clock period, which is time between successive transition in the same direction, and clock frequency, which is reciprocal of time clock period, and duty cycle, which is percentage of time that a clock is as at its assertion level. Here I show you some type of clock which you will see here. We can have the state change from low to high, which has happened here. And period of time is between changing the time, which we call it TL and TH, as you see. Or we can have active low one, which now we will put the observation from when we go for the low situation or change. In sequential circuits, any change occurs only on the application of clock signal, making it synchronous. Otherwise, the circuits it's asynchronous and depends upon the external inputs. Uh, Remember all these points, and then will help us to analyze these sequential circuits better. Just what I teach you for this lecture was some terms which give you some better maybe understanding and better perspective for this chapter, because in my point of view this chapter is much more important than other, and we should solve even more questions for this part. Okay, till now we talk just elementary part regarding the sequential circuits.